The Survey S15 dataset is a student-produced dataset from Duke University's Stats 101 course in spring of 2015. This was designed by the students that they would voluntarily respond to each question. From that original dataset, we want to determine if the amount of university applications is linearly associated with the amount of Facebook visits, using the amount of university applications as the response variable. So because of that, the number of Facebook visits is going to be our X variable. So for this, we need that Survey S15 dataset, which is this one. This is the original dataset. For this, we are going to go to Data. Let me first highlight this. And we need this to not be read-only, so let me very quickly save that. Okay. So, we have our data. We're going to Data Analysis, Regression. And for this, we need this entire B column here. So, the range will be all of this. And the X values will be all of the A. All of the A column. And then hit OK. And that's going to give an error because we need to actually choose all the way down to... Aha, there are a couple of blank variables in here. So actually let me cancel this. We need to delete these ones with no data in it, since it's not going to run nicely with that in it. And this one. So note this goes on to 176. So data analysis, regression. The Y variable is going to be from here and up. The X variable is here all the way down to 176. A lot of students were taking that class at that time. And then we hit OK for this. And it'll give us this. Right. Now, I'm going to say something about these plots in one second. But first we need our line of best fit. And as we can see from this, we have a coefficient of 6.4550 and our slope for the x variable to be negative 0.00009. So very small value. But let me put that in here first. We do have some things we could say about that, but I'll save that for a little bit before I say it. So that line of best fit to begin with was 6.455 minus 0.1234 zeros and then a 91x. Okay, we could run the corresponding hypothesis test, right? The null hypothesis would be that our slope beta is 0, or there's no association. The alternative being that beta is not 0. Again, there is an association. And that particular data from this, which was not this data set, here we go, this one, the t-stat is negative 1.06 and the p-value is 0.2889. Okay, so let me put that on here. T-stat was negative 1.06 p-value. That is a very bad p. P-value was 0.2889. 8, 9. If we use a value, an alpha of 5%, right, that is definitely well above 5%. So because of this, the there's no association to it, right? We can even see it with just the slope. That's very small. Since it's so close to 0, by itself, that automatically we could tell it's definitely not. If we look at those plots on here, this one looks almost like a logarithmic graph. This one shows all the data points here to the left, and in the predicted column, we have one value all the way over here, which just shows a line here being drawn, but most of the data is over here. And then finally, in this top residual plot, we have a whole ton of data here, and one, just one, all the way out here, which means there's definitely an outlier in here, and because of that outlier, it's incredibly inappropriate for us to even be running this. That outlier, if you look at the original data, is right here. 59,999 Facebook visits. That's definitely an outlier. We could simply get rid of this and then rerun this, which I have already. Stop putting that on there. I have already pre-done that. That being here, right? You could see no 59,999 anywhere on this data set. So, in order for us to now quickly just redo this, if I hit this data analysis box, again regression, we want the Y range down to 175 now, since we got rid of one data point. Along the same thing with the axis. And then hit OK. Right? Now we could see these plots at least look better. Definitely not perfect. We'll get to that in 1 second. But now we have our coefficient, our intercept being 6.5325, and the slope of negative 0.0073. So this is the old one with the outlier. The new one is this one. So y hat is equal to 6.5325 minus 0.0073x. So this is the one with the outlier, and this one that we just wrote is not. The new hypothesis test, let me reopen that. The t-stat is now negative 0.39 and the p-value is 0.7001. So the new hypothesis test, and this is beta was equal to 0 for the null hypothesis. Alternative was that beta is not 0. The t-statistic of this new one was negative 0.39, and the p-value is 0.7001. Now, just based upon looking at this p-value is still well above 5%. Deleting the outlier did not help it. And you can see this still looks logarithmic. I mean, we could see more of the data here, but we have a whole bunch just bunched over here to the left, and a couple more here to the right. The fact of the matter is, despite the fact that we got rid of the outlier, we have so many more outliers in here, right? There are way too many outliers now for us to be doing than just one, for that to be considered not with the data. We can't be doing all of those. That would definitely not be a good idea for that. And likewise, this residual plot up here, we have a whole bunch over here to the left. We have well more of the data above the line than we do below the line. Right? We have a whole bunch down here. And then, even as we go out, we have several of these outliers. If I change this to a histogram, we see we have this one bar here to the left, and it's swoop on down to the right. If I change these bins, let's see, this is 7 to begin with. Let's bring that up to 10. 10 is exacerbating the situation. So does 15. And so does 20. No matter what sets we use, we could see we have a skewed right distribution. Right? So because of all that, as I put this back onto a scatter plot, that's definitely not appropriate for us to be using at all with this. But we could certainly still write a conclusion for this test. And let me, hopefully, type this. And I did not want to do that. I only want to give myself more room. Okay. So comment on the conclusion of this test. This would be at the 5% level of significance. We have, we do not have sufficient evidence to reject the null hypothesis. Or to put it a different way, at the 5% level of significance, we do not have sufficient evidence to claim that there is a linear association between university applications and amount, and I should probably put an amount here, linear association between the amount of university applications and the amount of Facebook visits, with or without the outlier, as we can see what happened in both of our tests.